Oh, this is Mr. Precella, and today we're going to discuss square roots as we begin our algebra class. I'm clicking here, and when you look at this page here,
oh, this is important.
Right out here, again, it's set up for you to be able to do this as, at home. There's these lecture videos. Over here are the problems, but you'll notice you can't click on them. View the media files and questions listed below in the order listed. Questions that are not clickable will become available when you have viewed the required media.
You're here right now, so you probably won't need to watch that Mr. Precella's class lecture video on square roots that we did from home during the pandemic, okay?
But at the end of class, I'm going to pull this back up, and you'll see that, oh, wow, I'm just doing exactly on this video what we're about to do right here, okay? So let me close that.
But you've still got to click those videos. No, even if you're not going to watch them, you got to click them.
Look, I got the green check. I can close it up and go. Okay, this is a Pearson video, which has all the bells and whistles that mine don't.
Ours
don't, because of the, there's no transcripts, whereas Pearson has the transcripts and so forth.
That's
YouTube has gotten through. Yes, this is a dear friend of ours, Elaine Martin Gay. She writes math textbooks, and
pretty famous in math textbook circles. She's pretty famous.
But now that I've got this,
the checks.
Oh, there. Now we can start clicking. Okay, so I'm going to click on problem number 1, and we're going to start working this stuff. If there's any questions, unless there's any questions. Okay, go ahead. Oh, you go ahead. Oh, wow. How to make a good first impression. Oh, Tim's going to... You can turn your desks. If you're looking at this screen and want to turn those desks, then that's fine. That's what Tim's doing, is Tim's turning desks. You got to unlock those wheels. Yeah. Okay. So I'm going to click on this first problem. Turn the desk so that you can see whatever monitor or projector is posted. Oh, come there. Okay. Oh, wow. Let's see. What gets it bigger? You know what? I like it better when it goes to the person.
Okay, so number 1.
Yep. This is problem number 1.
Let me write it down.
Evaluate the square root. That's what our first assignment is. This symbol here is called a square root symbol, the one I'm showing there. And it's also a radical symbol. That's what it's another name for it. The number under the square root has a formal name, radicand, which I hardly ever say. I just said it, though. And so we're going to work problem 1. Square root of 144. Let me see about this focus.
Is it focused? Does that look focused to y'all? Yes. Okay.
So, what is the square root of 144? Well, what number can you multiply by itself and get 144? 12. Okay.
12
times 12 is 144. See, this is that first question I was talking about earlier. Everyone can do their problem 1 on assignment 1.
So we don't have to check that y'all never did anything. At least create your account, get the 14-day pass, and do problem number 1. Now, I don't know what number will be there. Probably not 144 for y'all.
Yesterday it was 25.
Yeah.
Yesterday we had small numbers. It looks like today we're going to have big numbers. So I click check answer. Says fantastic. We'll move on to problem number 2.
This number 144 is called a perfect square. A perfect square is a number whose square root is another integer. Before we go on to that number 2, why don't we write out some perfect squares?
Okay.
Let's switch over. Okay, let's write out some perfect squares. perfect squares. Well, 1 squared is 1. Well,
1 times 1. But
I'm not even going to bother writing that, okay? What about 2 squared? 2 times 2 is
4. So I'm going to write out the perfect squares. 2 times 2, 4. Oh, I can't even write a 4 today.
3 squared?
9.
4 squared?
16.
Okay, what's next?
What's
25, I agree.
And
after that, 36, that's 6 times 6. Next, 49, good. 64, what's next? 81.
Oh, what about 11 times 11? Do y'all have that one?
121. And 13 times 13 is 169.
And we didn't list that one yesterday, but since we've already seen problem number 2.
Oh, what was number 2?
Yeah, look at problem 2.
Oh, let's see. How do I do that? Oh, there. Okay. Oh, there it is. I have to say something. I always access the homework by clicking the My Lab and Mastering tab over here. Oops. I like it. I like to enter it
has
there.
less.
It looks better, okay? So is it okay for me, for y'all, if I switch over to this view, My Lab and Mastering, like that?
I bet you.
Okay.
No, go ahead and do it, because it makes the screen cleaner. Okay, open My Lab and Mastering.
So there's 2 ways to access your homework: through the little sidebar on the Canvas screen, but I prefer going into My Lab and Mastering, clicking Assignments, and then I get rid of this little sidebar here on the left side, and we're doing homework number 1. And now I'm going to click number 2.
And okay,
there it is.
There it is. Square root of 169. What are we going to type in here? 13.
Now, if you don't know, you have your calculator. I said you need a calculator for number crunching. If you're using an 83 or 84 like this, notice the little square root key. It's in yellow. That means you have to press the second, and then, oh wait, I better turn the thing on,
and clear all of that.
Second square root. You see the little square root symbol there?
Mm-hmm.
And what am I going to type now? 169. And sure enough, you get 13. So you're going to want to have a calculator right from the start for things like number crunching. So I'm going to write in here 13. And down here I'll check answer. And it says, good job. Next question. Now notice 169 was also a perfect square. We're going to be getting to problems soon that are not perfect squares. Let's see. Oh, I think, is 18 a perfect square? Look at that. Write the problem down. The square root of 18. Oh, let me get rid of this thing here. Okay, there's the square root of 18. I'm going to switch over to the tablet where we're working these things.
And 18 is not a perfect square. Okay? So how can we simplify it? We don't want a decimal. Algebra does not like decimals, so you can't just put square root of 18 into a calculator and write down a decimal number. Pearson doesn't like decimals. If you find yourself entering a decimal number, you're probably messing up somewhere. So here's how we're going to simplify something that's not a perfect square. We're going to rewrite it as multiplication. We're going to rewrite that number 18 as multiplication using a perfect square.
Ask yourself, what's the biggest perfect square that divides evenly into 18? By dividing evenly, I mean there's a remainder of 0.
Which one of these numbers divides evenly into 18?
There's only one of them.
9. We can think of 18 as 9 times 2. So I'm rewriting 18 as a square root of 9 times the red square root of 2. Oh, the camera's been moved. I'm here trying to figure out why. Okay, my paper looks straight, but no. Okay. Now, once I have it written, this the green square root of 9 times the red square root of 2. I'm going to rewrite this green square root of 9 as what number? 3. Y'all following the colors here? The square root of 2 we just leave under there.
Can you see your own paper?
So 3 square root of 2 is how we're going to simplify the square root of 18. Now,
how are we going to type that in?
Yeah.
Okay. Here's something. When you run, we didn't mention this in our class yesterday, and we probably should have. Okay. When we're if you're, say, stuck on a problem, y'all see this little gear thing here that says settings? Well, that's not.
No, it's view an example down here.
Oh, there it is. View an example. Oh, I have to discuss it. It's written right there. I thought it was hidden under settings. Oh. That's where you get the print thing. But if you need to, I'm stuck on, I want to see an example, you can say view an example. And it's a very similar example, and they'll talk their way through it.
45, their writing is 9 and 5. Oh, wow, I had no idea there were so many steps.
I'm just saying, my goodness, they take a lot of steps.
You see, I would have done,
okay.
I was going to, what I do is show the continue. Okay, I would have written right here, use the mouse to show. Square root of 45. I wouldn't have written this. I'd go straight to this and get that. Okay?
That's what you did.
Yeah, and that's what I did here on the square root of 18.
And let's see. So let's.
You click in the box.
I click in the box, you'll notice this toolbar down here appeared. If you have to type special symbols, that toolbar will appear. Now, if you're trying to type a special symbol and it's not appearing in the toolbar, then you're typing something you don't need to type. You shouldn't be typing. But the toolbar will not appear until you click inside that blue box. And then what do we have to type? We have to type a 3. And then we need a square root. Looking down here, do you see anything? There it is. That looks like a square root, and if you hover over it, can you see that tiny print? What does that say?
No,
square root. So square root of what goes underneath the radical? 2.
Check it. Okay. Now, one semester, I remember years ago, a little student, she was so sweet, said, I can't do this. In high school, we always had 100 problems, and I need more problems. And I said, you can do as many problems as you want. Right here, it's hard to see, the similar question button. Let me hide this. If you want to do another problem like number 3, just click similar question. That's also what you should do if you get it wrong. Okay? You should work it until you get it right. But you can click similar question. Let's see. Square root of 90. I'm going to go ahead and do this one. Just as another example. Tim? Are you showing it?
There it is.
Square root of 90.
Oh, I think I know what the biggest perfect square is for that. It seems like number 3, the biggest perfect square is always going to be what? 9.
So what am I going to write that as? A green 9 and a red 10? So what are we going to type in for the answer? It would be 3 square root of 10. So if you get one wrong, you can always get it right by just saying similar question there.
That brings up another topic. Your goal should try to be, even though there's only a 70 prerequisite for you to go on, your goal should try to be to make 100 on every one of these homework assignments, and it is not impossible. You can keep on working the problems, and it's not like each assignment has 50,000 problems. Most of them, I think about the longest we have is 25 problems.
This one has 20, and it's one of the longest.
And so
the next assignment will have 15.
If you miss a problem, rework it by saying similar question. Also, I mentioned that you get to use your notes during the test. a student was asking yesterday, can they print the homework? And we were like, well, we need to check and see. We should have it set so that printing is allowed. But now, go to the little gear symbol, click print, and ask, do you want to print this question only or print the entire homework assignment? So I'll say the whole homework assignment, and then I'll print it.
Well, go ahead. You've demonstrated enough. I don't think, you see, there it is. The three I've already done are showing there.
They already have the answers.
But we don't have a printer connected to this, and we don't really need to make another paper copy of it. Okay? So let's switch back so we can work this one. Does anyone have an idea of how we're going to rewrite 75?
Is 75 a perfect square? No. What's the biggest perfect? 25, I agree.
Y'all hear that?
Now, here's something. If you're just uncertain, okay? You're just uncertain what perfect square might divide evenly into a problem, then
get your calculator.
Do you agree it'd have to be smaller than 75? So just start here at 64 and work your way down until you find a problem.
Let's see.
I mean, the number that divides in evenly.
Where's my
Calculator right there.
Oh.
I changed the dot symbol.
Oh,
and
well, there it is. Okay. So this is my thought process. Okay, which one of these numbers divides evenly into 75? I'm sure 64 doesn't. 49, what about 36? And I'm just thinking, 75 divided by 36. No, there's a decimal. 75 divided by 25. Okay, yeah.
That's where you get the integer.
So
the number that's left under that radical cannot be divisible by any other perfect squares, though. There can't be another perfect square that divides in evenly. That's why we say you use the largest perfect square.
Now, how am I going to write this? A green...
The square root of 25.
5 square root of 3. Oh, okay. Type that in, Tim.
So, I come back over here. I type in 5, and then what do?
Hit the square root key, Tim.
And underneath the square root, I have a
3.
Any questions?
Let's see. Simplify the square root. If it's not simplified, state so. So it's possible.
It can't be simplified.
Yeah,
it's already simplified enough.
So square root of 38.
Let me switch. The square is 38 a perfect square? Okay. So what's the largest perfect square that divides evenly into 38?
I'm showing my thought process now. 38 divided, I'm going to start with the biggest one. 36 certainly is too big. And I think all of us would probably discard 25 pretty easily. Oh, wait, what happened? Oh, wait.
What's the DE?
38 divided by 25. 38 divided by 16. What about 9? 38 divided by 9? Does that go into it? No. What about 4? No.
So what do you conclude? Is there a perfect square that divides evenly into 38? No. So
can't be simplified.
If there's no perfect square that divides evenly into the number, then the square root can't be simplified. And in that event, what am I going to do here for the answer?
Well, it's already been simplified. That's what they say.
Okay, so I choose option B. Any questions? Oh, have y'all noticed? As we do the problems, every time you get a green check, your score is going up. We're on problem 6. We've done 5 of them, and our homework, if we stop right now, our homework our homework grade is 25.74. So,
but why would we stop right there? We're going to make 100 on this.
Back later.
Oh yeah, you can stop at any time. They used to not have the save button because it saves it automatically.
when
But students kept wondering, oh my God, how do I save my work? So they put a save button there. But you could just close it out and it'll save it. Okay?
Okay, the square root of 50.
I've written it down.
Oh, let me switch. There.
Well, let's see. Well, do y'all have an idea of what perfect square? Yeah, 25 times 2. And so I'll have a green 5.
The square root of 25 becomes 5.
5.
And the square root of 2, we
Yes.
just bring it. Any questions? Y'all are so quiet.
They are.
Okay. You're not going to circle that, Tony?
Oh.
Always circle my final answers. It says that to me,
It's over. You're putting it behind you. You've done that
I've
problem.
done that problem. I'm moving on to something else. So 5 square root
Wait.
7. 5 square root 3. Suppose I type 5 square root of 3.
We want to demonstrate what you do if it's wrong.
Uh-oh.
Oh, it's
And they give you a little note trying to help you. It's always, to me, I'm sorry, this little helpful note is always so convoluted, you know.
wow.
But
Okay.
still, I shouldn't be saying that. These notes are very helpful.
Okay. Pay close attention to them.
Oh, and let's say you have
Put
3
it on B.
chances.
Let's guess
Let's
B.
say B now. Let's check that.
We're going to deliberately get this problem wrong. There's that helpful note. It should
You have
explain
3
everything.
chances to get the answer correct. So this is my last chance.
Look, it says final check. We can only check it once more, and at that point we're going to get an X.
I think should I get an X?
Yeah.
Okay, so I'm going to put a...
Oh, it told us the right answer, which is what we had, 5 square root of 2. And it tells you your answer. Then it gives you an option. Do a similar question or go to the next question. What should we do in order to get it done right? Similar question.
Don't
Okay.
leave those X's. Do a similar...
Oh, my God.
Sometimes that happens.
Oh, wow. Okay. Well, then, we
Sometimes
got
that
lucky,
happens.
so
Look at
punch
that.
it in now.
Look at the similar question. It's the same number. Okay.
Oh.
I think they knew we'd worked it right, and we were just sort of, playing
Demonstrating.
around. So, there. Is that what I wanted to type?
Uh-huh.
I'm asking the class.
Oh.
You keep answering my questions,
Oh,
Tony.
okay. Okay.
Oh, goodness.
Oh, wow.
Oh.
No, number 7, the square root of 72. Oh, this is a really good.
Oh, look, by getting that question right, notice our score's gone up to 30.69.
But
Okay, see? And now, students always ask, what is this thing here, the little asterisk and stuff? This problem just came from a different textbook. That's one thing about my lab. It doesn't really matter what book you're using. If you say, oh, I like this problem from this other textbook.
well, they don't say
Y'all
that.
can't say that. Teachers have the ability to do that. A lot of our colleagues don't realize that. But
But I like to.
I like to pull stuff from other textbooks. And okay.
Whichever one I think. Okay.
I'm going to let y'all tell us, okay? Is 72 a perfect square?
I'll come here so they can see.
Oh, yeah, I forgot.
Now,
Is 72 a perfect square?
no,
No.
and 72 is interesting because when you look at the perfect squares, 9 divides into it, right? But
I think there's a bigger one.
bigger one. What's the biggest? 36. 72 divided by 36 would be, yeah.
You have to use the biggest perfect square that divides in evenly. 9 times, what would there be under the radical? If you used a 9, 8, 8 is still divisible by 4. The number that's under the radical cannot be divisible by any other perfect square.
So 6 square root of 2.
This is actually a very important problem because the fact that there's more than one perfect square that divides in evenly. that you use the biggest one. Any questions there?
If you use 9 and 8, you're going to get it wrong because 8 is under the square root symbol then, and it can be simplified.
8 can be divided by 4. Oh, okay.
So type in 6 square root of 2.
6 square root of 2.
We still have a lot more to go on simplifying. Number 8. Square root of 250. So at this point we might, maybe I have too many of the same type of problems, but okay.
It's good practice, Tony.
For 250, do you have an idea of what perfect square?
Well, first of all, let's see. Do you think this is 250 a perfect square? No, because it's 15.8 something. So that's not a perfect square. But what's the largest perfect square that will divide evenly into it? Someone was saying it.
25. 25 times what would give us 250? Yeah, so we think of this as 25 times 10. So
now realize, is there any number up here that would divide evenly into 10? 4 and 9, would they divide evenly into 10?
No.
No, you see the number under that radical can't be divisible by any other perfect square. Okay.
So we have a green 5 square root of 10.
Any questions there? Okay, so I'm going to come over and I'm going to type a 5. Oh, and by the way, this thing here, this is for cube roots and fourth roots, what have you. And we'll be seeing some cube roots eventually in the course, okay? But for now, we're only dealing with square roots. Square roots are by far the most common radical. And what was under it? 10?
10.
Yes.
Okay. 9. Oh. Okay.
Wait, well, sometimes
I was here
happens.
thinking that maybe we had switched over. That I had too many of these.
It looks like it's a repeat.
And so okay, so what square root of 72 is what?
We just had that on number 7.
Yeah.
Sometimes the way the numbers are randomly generated, we will repeat the same thing. Okay. But sometimes the problems they give you may be what we did up here in class. Most of them will be slightly different.
Yeah.
Okay.
But so we just type in 6 square root of 2. I was here thinking just now maybe y'all are getting bored. I have too many of the same problems. So this is a good thing. Oh yeah. Oh, okay. Here's a good one. Number 10.
Maybe 375 is a perfect square. Let's see. If we punch it into our calculator, do we get an integer back? No. No, we don't get an integer back. So.
Oh, gosh. 375.
375. Let's see. Well, let's see. On our little list, we had 169. That was the biggest perfect square we wrote, but it kept going on and on. Okay.
So 169 doesn't. I don't think 144 is. If you want to just
any idea?
20.
I think it's going to be another 25. Let's see. Let's take no.
Clear that.
375 divided by 25. 15. Okay. Will a perfect square divide evenly into 15? It has to be a number smaller than 15. Does 4 or 9 divide evenly into 15? No, so that's the one you want. 25 times 15.
Okay, that's a very good example, Tim.
Well, thank you
for showing the thought process. What am I going to do? A green 5.
And what do we do with the 15?
Leave it under the square root.
Any questions there?
Oh, wait. Can y'all see what I'm writing? Yeah, okay. Hold on. Okay. 5 square root of 15, and we're halfway done. And we need to discuss, do y'all want to take a break right now or keep going?
We're going to be 3 by 4 if we just keep going. Keep going?
I think we'll be 3 by 4.
If you have to, have to leave, we didn't talk about telephones, okay? If you have to take a phone call, try to remember to silence your phone before you come to class. We'll do the same thing, but we'll forget from time to time, okay? And if you forget and it starts ringing, don't panic. Just silence it as quickly as possible. Tony and I will act like we don't even hear it. If it's an important call, step outside and take the call. So, restroom. You need to go to the restroom?
Just go.
Just stand up and go. There are 2 exits. And, just quietly step out. If you have to step out and for any reason, I think we've already done this one, haven't we?
So we're getting a little lucky here. Number 11. We've already done square root of 250. It was number 8. So I'll just say, and number 11. There. Okay, 5 square root of 10.
It's just this first assignment, but there's not this much repetition on all the other assignments. Don't get all excited thinking, half the problems will be the same as the ones I've already done.
Now, I am looking at this thinking maybe I should have shortened the assignment a little. Maybe I had too many of the same problems over and over.
Now it's changing.
Okay.
We're no longer just simplifying. We're taking a square root times a square root. We're multiplying square root times the square root. To multiply a square root by a square root, you just keep the square root and you multiply the numbers underneath them.
The square root of 3 times the square root of 15.
Okay, they've written it down.
Let me lower this. To multiply 2 square roots, just write down the square root symbol and multiply the 2 numbers together. 3 times 15 is 45? Yeah, I agree with that. But be careful. Math builds.
Now you have to use the simplification method that we've been using to simplify the square root of 45. Is 45 a perfect square?
No, but
what's the biggest perfect square that divides evenly into it?
9.
Okay, so you're thinking of it as the square root of 9 times the square root of 5.
So I'm going to have a green 3 square root of 5. That's the answer. That's the thing about math, the way it builds.
That's why we have those prerequisites on the assignment.
See, number 12 would be really hard, probably. If we had it already discussed, this part right here, you'd be thinking, wait, what the heck is he doing? Okay? So 3 square root of 5.
Any questions on our logic? Okay, let's go type in the answer. We have a 3 and a square root of 5. Any questions there? This brings up a good point here. This one?
I like this one, yeah. Square root of 11, dot for times, square root of 11.
Now, remember we said if you're multiplying a square root by a square root, you keep the square root and you multiply the numbers underneath there. So we keep the square root. Wait, let me come over here.
And let's do this.
Okay, 11 times 11.
Clear all that.
Wait, that's too busy, isn't it? There. 11 times 11 is 121.
Do we know the square root of 121?
Yes.
What is it?
11.
It's 11. Okay.
So the square root of any positive number times the square root of any positive number gives you that positive number.
I'm going to write a rule down.
Tony's going to write
this
a rule.
This is a red rule. And this rule we're going to use off and on all semester. Okay? The square root of A times the square root of A equals A.
And that's what we have here. The square root of 11 times the square root of 11 is just 11.
You know, let's go back to number 13.
Number 13.
Oh, you haven't punched in the answer. Punch in the answer. Check it. And now, let's do another number 13. So, X that out rather than go into the next question. Say similar question. And, oh, wow. Could y'all tell me that answer without any work? 23.
That's right.
Okay, it's very important rule that square root of A times square root of A equals A. Such an important rule that we're not using it again now.
We'll use it again.
We'll use it, yeah. Square root of 6 times the square root of 18.
Yes.
We might want to use a calculator on this.
You could have turned your table to face the projector. It just now dawned on me. You could have turned the table the next time, I guess. Okay. When you get here next. Oh, okay. I guess you're young. Me, if I had my head twisted like that, I'd be going to the masseuse the next day.
Okay. Okay. Square root of 6 times square root of 18. Okay, so 6 times 18 is 108. So square root of 108.
Remember, you keep the same square root. You just multiply the numbers under the radicals.
But let's see, what perfect square divides evenly into 108?
Do you agree 108 isn't a perfect square?
It's not. 81's too big, 64, I'm pretty sure 49 does that, but go ahead. 108 divided by 49.
108 divided by 49. I think that's going to give us a decimal.
No,
that's not.
So what about 36? 108 divided by 36.
There it is.
Okay, so 36 times 3. This is another one of those that
we have to reduce using the technique that we saw earlier.
Using the biggest number possible. Because if you start 108 divided by 9, you see 9 divides into it, but you're not going to use that. Even at 4, doesn't 4 divide into it? Okay? But don't use 4 or 9. Use the biggest number. That way
12 is divisible by 4. 27 is divisible by 9. So they have perfect square divisors. The thing under the radical cannot be divided by another perfect square. Divided evenly, I should say.
So the square root of 36 is just a 6. Square root of 3. Any questions? 6 square root of 3.
So we come over here and we write 6. Square root. Okay, pop quiz. If I mess up entering this answer, how many chances do I have to enter it correct? 3. Okay.
And then you have to do a similar question, and maybe you'd get lucky and it'd be the same one you just got wrong, and you can just type in the answer, okay? But maybe not. Before we do problem 15, I want to recall something called combining like terms. I say recall, it's nothing I've said today, but in a previous class, math class, you would have done stuff like this. 3x plus 6x. And you would call those like terms because they're both x's. And it'd be like 3x plus 6x, that's the same thing as 3 cats plus 6 cats is 9 cats, so 9x. But if you'd had an x and a y, can you combine those? No, okay?
3 cats plus 6 dogs
Well, I guess you could say non-animals there. But,
You're right.
Yeah,
You're
but
right.
don't do
That's
that.
a bad
Okay.
example.
Yeah, it is a bad example.
Bad
3x
example.
plus 6y can't be combined. Now, why am I mentioning that? Well, on problem number 15, we're adding square roots. 5 square root of 6 plus 3 square root of 6.
To add or subtract radicals, you have to have like radical terms. They have to be the same type of radical. They're both square roots. That's good. But they have to have the same things underneath them also. So they have to have the same radical and the same radicands. And we have that. Square root of 6, square root of 6. At that point, adding and subtracting radicals just becomes basically combining like terms. They're like terms, so you keep the same radical part. You keep that part
Just like you keep the x's here. So just add the 5 and the 3. 5 square root of 6 plus 3 square root of 6 is 8 square root of 6. Here. Okay, 8 square root of 6.
Adding and subtracting square roots is the same as just combining like terms. You have to have like radical terms, then you add or subtract the coefficients, depending on what they tell you to do. Here they say to add. Okay, any questions there? Okay, so I'm typing in 8 square root of 6.
Oh, 6 square root of y plus 8 square root of y. Sometimes students say, oh, I can do these answers without writing. I can get the answer without having to write down all that stuff you're writing down. Do I have to write all of that stuff down? No, no, no. Your goal and my goal are different. Your goal is to get the correct answer as fast as possible without resorting to cheating using photomath. But, my goal is to try to show the thought process. So I think probably, having seen example 15, most people can probably do 16 without actually writing it down. 6 square root of y plus 8 square root of y. Do y'all want to tell me what you think it's going to be? 14 square root of y. Perfect.
You keep the same radical part. You add the coefficient 6 plus 8. If that were 6y plus 8y, it'd be 14y. Adding in that square root doesn't change anything. The same logic is still the same. Okay, let's punch that in. 14 square root of y. Has it stopped raining or is it still raining?
I think it stopped, right? Looks like it stopped.
Oh, good, good.
Oh, look at number 17. It's going to...
Let's write that down.
6 square root of 6 minus 3 square root of 6 plus 2 square root of 6. Y'all have a feeling that there's going to be a square root of 6 in the answer? Yeah, okay. What's the number? What number are we going to have in front of that square root of 6? Okay, 6 minus 3
Wait, let me switch over to your page.
is 6 minus 3 is 3 plus 2. I agree with 5. Yeah. So 5 square root of 6. To add square roots, just keep that square. You got to have the same square roots. Same thing under the square roots. And then just add the numbers in front.
Now, if this were a square root of 5, and this were a square root of 6, and that was a square root of 7, nothing we could do. You have to have the same number under the radicals, and if the same number isn't there, you have to use that simplification technique to get the same number. And if you can't
we're going
get
to
the
show
same
that in a
number,
moment.
I think that's the, oh, wait a minute. What's this answer? I forgot. 5 square root of 6? Look at this one.
Okay. The way math builds on it. 6 square root of 80 minus 8 square root of 5. Well, at first glance, you don't get the option of can't be simplified, okay? They don't give you A and B. At first glance, I would think, oh, wait, they don't have the same number to the square root. But wait a minute. Something we did earlier.
Well, first of all, 5 is a prime number. Do you agree there's no perfect square that will divide evenly into 5? So maybe we can change that square root of 80. What do you think?
Okay. Let's see. So we're now going to try to do what we were doing here on problems 3 through 11 when you were thinking I was beating a dead horse. We had too many examples like that. Hey, square root of 80 isn't one of the examples we did, is it? No. Oh, 80. 4 would go into it, but I think there's a bigger number. Okay, if we think about 80, so, 36, 25, what about
16?
16. Try that. 80 divided by 16? What? Okay, a 5. Is that good news? I think it is now.
Because remember, you have a 5 under the other one.
Okay, so I'm going to... Oh, Tim. How is this showing the...
I had it there,
okay.
but that's it.
Oh, okay. 6. I'm now going to rewrite the 80 using green and red. I'll have a green 16 times a green square root of 5, a red square root of 5. So we have, So I'm carrying down that black 6 times, what's the green number? Is it 4?
Square root of 16 is 4. What do we do with the square root of 5? Bring it down.
So we have what? 24. 6 times 4. 24 square root of 5 minus 8 square root of 5. Is this something we can now simplify? Or subtract? Yeah. You see how we rewrote the 6 square root of 80 as 24 square root of 5. Are there any questions on how I did that?
This part right here is the important part.
Because now all I'm going to do is what? 24 minus 8. Y'all getting bored? Is that going to be a what?
16.
16 square root of 5? What are some wrong answers probably? Maybe a square root of 0. Do you think some people might subtract the 5s? That would be wrong. Okay. The 16 square root of 5.
Before I punch it in, any questions? I know we've been rambling on for a while. I'm afraid we're starting just to say stuff and it hit you in the face. And bounce off. Have a mighty quiet. 16 square root of 5. Any questions there? No?
Well, the next problem is going to have a word that I need to define.
Switch over.
It says, rationalize the denominator. So, the phrase rationalize a denominator, the denominator is what part of the fraction, the top or the bottom?
The bottom.
Yeah. Okay, rationalize the denominator means rewrite the problem so that there is no fraction under a square root and no square root in the bottom of the fraction. What the heck does that mean? It's not as hard as I'm making it sound with that terrible sentence there. When the instructions say rationalize the denominator, that means that you have a fraction. If there's not a fraction there, then you don't need to rationalize it. Okay? But you're going to write it so there's no fraction under a square root. We don't want this. You don't want a fraction under a square root. And at the same time, you don't want something like this. A square root in the bottom of a fraction. When we're working with fractions that have square roots, we want those fractions written where the square root symbol isn't in the bottom, and at the same time, no fraction under the square root symbol.
You can have the square root in the top. It's fine to have a square root in the numerator. You just don't want a square root in the denominator. And with that in mind, let's look at number 19.
The square root of 10 over 7. And the instructions say rationalize the denominator. So we're going to rewrite this fraction. And I'll show you how we're going to do it. Okay. When you have a fraction under a square root symbol, that means that the square root symbol goes on both of these numbers. So I'm going to make it for a moment look messier by writing it as square root of 10 over square root of 7. That's what that fraction under the square root means. The square root goes to both numbers. Now,
so at this point, we've gotten rid of the fraction under the square root, but we've picked up a square root in the denominator.
So we need to get rid of that square root in the denominator. We just want a 7 down there, not a square root of 7. Let me go back.
You made a rule earlier.
My red rule. Look at my red rule. A square root times itself. Do y'all remember that rule? Square root times itself gives you just the number under the square root. This is going to look strange for a moment.
Remember, you can multiply a fraction above and below by anything you want to and maintain equality. As long as you're not multiplying. You can multiply by any other number. So we're going to multiply that square root of 7 down there by itself.
But whatever you multiply the bottom by, you got to multiply the top by. So, in other words, in a minute I'm going to write a sentence that says, to rationalize the denominator, multiply above and below by the square root in the denominator. So that square root of 7, I'm multiplying above and below by that. And what are we going to have? Well, let's do the bottom first. What will be in the bottom? Just a 7. That's what we want. Now, what about this top? Do y'all remember how to multiply two square roots together? Just a 70. So we have square root of 70 all over 7.
Is 70 a perfect square? No, it's not a perfect square. Is there a perfect square that divides evenly in?
I don't think so.
What do
you
y'all
started
think?
70
around. All I can think of is 7 times 10. Neither of those are perfect squares. They don't have any perfect square factors.
35 times 2 is also 70, but none of them are perfect squares, so square root of 70 can't be simplified. So this is how that fraction should be written. Instead of the square root of 10 over 7, it should be written square root of 70 all over 7.
And don't go cancellation crazy. If you had 70 over 7, you could cancel a 7 above and below and get a 10. But
Don't get a 10.
70 is under a square root. This 7 isn't. There's nothing you can do to simplify that. Your final answer will be the square root of 70 all over 7. And I think this is the first time we're going to punch in a fraction. So let's look at this.
Oh, so often students will send me screenshots and say, it doesn't show the tools. How do I get the square root
You've
symbol?
got to click in the box.
Click in it first.
And then it shows the toolbar.
So how do y'all think we would punch in this fraction? Well, hit that first hot button, Tim, the fraction.
Notice if I hover over it, it says fraction.
Oh, Tim,
so I click there.
I don't think that they need, I think they can tell that's a fraction.
Well, we'll see.
Okay.
I think you're getting eager to get
I am.
out.
We're almost done.
I know.
So,
Okay. Oh, what do you think I'm going to click next? Y'all tell me. A square root. And what am I put under it? 70. And in the bottom, I put a 7. I click down here at the bottom and type my 7. I check my answer, and any questions there? Surely the next one will be a little messier. What do y'all think? It's the last one.
it's the last
Hey,
one,
look at-
so as I always say, the last problem has to be the hardest. So let's see it.
Hey, look at this.
Oh,
We've got that. We're up to 95.05. We only have one problem left. You don't get very many. You don't get much credit when you click on the videos because so many people don't actually watch them. They just click on them, and so they're not worth a lot of points. Most of the points are from doing the problems, but you still got to click those videos. So even if you're not going to watch them.
oh, no, I'm going to write a sentence. So flip the screen,
Write
Tim.
one of your famous sentences.
Yeah.
Oh,
Okay. So I've already done this long thing about rationalizing denominators. Now I want to say what I did right here. To rationalize a denominator, multiply above and below. If you take trigonometry, you'll be doing this a lot, this rationalizing. By the square root in the denominator. So, on this one here, I'm going to multiply above and below. Sometimes people say by 3 square root of 5. No. I didn't say, I just said multiply by the square root. You don't need to multiply above and below by 3. You won't
get it wrong, there'll just be more reduction. The numbers are going to get bigger if you do
bigger.
that.
All you have to multiply is above and below by the square root of 5. Now, let me see. How is that going to work? On the top, we have 25 square root of 3 times 5. Well, square root of 5. Well, I'm just going to write down the 25. And how do I multiply those two square roots? The square root of 3 times the square root of 5 is square root of 15. Now, what about on the bottom? Well, we have the 3. And
the square root of 5 times the square root of 5 becomes
25.
the square root of 25, which is 5.
You see that square root of 5 times the square root of 5? I used that little red rule of mine. There's my red rule right there. So, move all of that out of the way. And you'll follow what I've done here. Multiply above and below by the square root that's in the bottom. So that's why I'm multiplying above and below by square root of 5. On top we have 25 square root of 15. On the bottom we have a 3. And then square root of 5 times square root of 5 is where I'm getting that green 5. So, I'm going to run out of room. That's 25 square root of 15 all over 15.
Hey.
But we're not finished yet, are we? What else can I cancel?
Can I cancel the 15s?
Yeah, can I cancel those 15s? Say no.
Remember I said you can't cancel something under a radical with something that's not under a radical.
What about the 25 and the 15? What could I divide each of those numbers by?
They have a common factor of 5. You can cancel common factors in the numbers outside of the radical, just not something that's under a radical and something that's not under a radical.
So the 25 over 15, if I divide both of those by 5, I'd get a 5 here and a 3. And I'm sorry, I've sort of run out of room there. Is it clear? It's 5 square root of 15 all over 3. That's going to be fun to punch in.
But before I punch it in, I want to draw attention to this 25 over 15. 25. If you just had the fraction 25 over 15, you know how to reduce that fraction. That's really what you're doing right here. You're saying 25 and 15 have a common factor of 5, so cancel a 5. 25 divided by 5 is 5. Cancel a 5 in the denominator. 15 divided by 5 gave us the 3. So that's that 5/3 and the square root of 15 on top. Any questions there?
Ready for me to punch in the answer?
Mm-hmm.
So, gotta click in the box before you see the tools.
Okay, y'all tell us. This is the last one.
I won't click it until they tell
Y'all
me.
tell me what to punch first.
Fraction.
Okay, and then 5, and then 15. I agree. Just a 3.
I'm not sure that we're going to do much rationalizing denominators this semester. It might pop up once or twice. Trigonometry, you'll do a lot of it. If you take trigonometry, most people don't.
You'll keep getting that 1 over the square root of 2.
Right.
Hey, I have an idea. This pops up a lot in some classes. Let's do this one. Let's rationalize
One more
this
example,
one.
and then we're going to call it quits. 352.
1 divided by the square root of 2.
Oh, by the way, my brother and I both had the same 8th grade teacher, and she told everyone that we had to put a little thing right here to end the square root
I
symbol.
still do that.
I got rid of that. I stopped that habit years ago because it looks like an decades ago. It looks like an exponent of 1.
I close off my square root symbol.
And Ms. McGowan would be so proud of you. Okay?
You know, I think that she's passed. Okay,
I know, but
Tony.
she would be.
I'm sure she still is. Okay, y'all tell me, what am I going to multiply above and below by?
You rationalize it.
Okay, the square root of 2, all over the square root of 2, and 1 times the square root of 2. 1 times anything is anything. We won't even show that coefficient of 1. Just like with the square root of, we don't write 1x, we just write x. So if the coefficient is a 1, we don't have to show it. What's the bottom? The square root of 2 over 2 is the same thing
When
as...
you're taking trigonometry, you'll remember. Oh, you won't remember he did that. But still, it'll pop up over and over and over. It'll eventually get to the point where you just memorize.
1 over the square root of 2 is equal to the square root of 2 over 2.
Boy, I'm giving you so much to look forward to when you're taking trigonometry. Okay, now, we've made 100.
Hey, look at that.
I'm going to go ahead and say save.
For no other reason. It's already saved, but it just makes people feel better.
Okay. And now, let's see here. You see, look, there's everything with checks in it.
I'm going to take this video. Have you stopped recording? I'm going to take it right now and upload it to our YouTube channel. And I'll put it on the playlist. And it's amazingly similar to what we did on Monday.
Oh, yeah,
yesterday.
right. I promised y'all at the beginning, once it was all over, I'd click on this,
Now this one was made at home,
Yeah,
remember, so it looks a little different.
because I had a webcam, so I'm showing myself going through, talking about square roots. Oh, and there's no sound. Let's see. Oh, there. Oh, I hate to hear my voice.
One of these numbers that divides evenly into 50. Like 25.
No, no.
The
Okay.
punching.
Square root of 50.
Square root.
I'm going to go ahead and...
Right.
Hey, let's fast on through.
Go to the last one.
Let's look at the last problem. There's number 18, very much like ours that we did. So, remember years ago when Tim and I started our project YouTube video, a co-worker told us, oh,
Look at that number 20 there. It looks very similar to what we were doing on number 20. But it has a 21 over a 35, and you can cancel a 3.
No,
you
a
can't.
7.
A 7. What am I saying?
Yeah. The teacher told us, oh, you're just encouraging your students not to come to class.
And that's not the purpose, okay? But
Then when the pandemic hit and me and Tim just sat back, our classes were ready. They didn't need to come in and see us. Oh, wow. We're living in the past, I suppose. But, I think I even did another one. But anyway, there it all is. Video, our internet's messing up
I'm
here.
just giddy. I'm just giddy. After 2.5 years of not being in front of a class, I have to say, yesterday and today, I'm ashamed to say how much I've enjoyed this. So, you're not still recording, are you?
Now